Welcome, everybody, to the N3C Community Forum. And we're going to have three very interesting talks. First one by David Sahner, Good Algorithmic Practice Initiative, Rationale and Overview, and then two additional talks that I'll introduce. But before we do that, I'm going to introduce the N3C Enclave usage survey with the link on the agenda, and we're asking people to please complete the survey on Enclave tools. That'll be very useful to help us improve our support for the platform. And I see the link is also in the chat. So that's great. And so today we're going to start out with Good Algorithmic Practice Initiative, as I've said, an update from the Logic Liaison Team, following that Johanna Loomba, and then update from the Education and Training Domain Team from Shawn ONeil, and upcoming in the future next week. Oh, could you go? Oh, next. Okay, thanks. Next week we have data quality considerations for evaluating COVID-19 treatments using N3C, and by Haitham Sidki, principles for accommodating missingness, which is obviously a key thing in this sort of work, and their role in analytic decision frameworks, and MLP team update, task clustering pipeline, and GAP insights by Peter Robinson and Justin Reese. The missingness will be by Ken Wilkins and Harold Lehman. Then we'll have rare diseases and the rare disease networks, and the new N3C public health dashboard. The week after, week of the 18th, semantic clustering and monthly recover long COVID project team updates by the folks we're listing as presenters. Then April 25th, surprise presentation, and May 2nd, practical machine learning for COVID-19 using EHR data by Brad Price and Miriam Kodarviki. Okay, so, and Johanna Loomba needs to be promoted to panelist. Okay, and okay, we have some promote to panelist requests. 4.5 million COVID positive cases in the Enclave. Actually, it's almost 4.6 million. So it's still growing, unfortunately. But it's quite a comprehensive collection, 12.6 million people. Next slide, please. And I think our first feature presentation. So David, I think you can share your screen.
I will attempt to do so. Okay, can you see this?
Yes.
Okay, great. Well, thank you all. And I'm here to talk to you about an initiative that's formed in the last few months, but that capitalizes on the efforts of many individuals, as you'll see. We've come to refer to this as the Good Algorithmic Practice Initiative, and I'm here to provide an overview. There will be ensuing presentations from members of our core team today and next week. So without further ado, I'll get started. My goal is to
David, sorry, this is Sam. If you can swap in display settings, you're showing the presenter view right now. So if you just go up top where it says display settings and just swap views, if you can see on your screen.
Okay. Swap views. Let me try one more. Of course.
No, no, not that, Dave. If you see, if you see up top,
Yeah,
see where it says display settings, you want to turn that captioning feature off, but you see where your mouse was, if you move up, there's a little configuration icon that says display settings, and you just click that and you just swap the view.
right. I haven't actually used this functionality on Zoom before as a panelist, and I ordinarily don't have a problem displaying slides.
No, just share again. It's okay. Share your screen and let's see what shows up.
Okay. Let's see what happens if I try one more time. Can you see that first slide?
We can, but if you want to put yourself in presenter mode now.
Okay.
Yeah, you're in a normal state, so I think it'll be okay.
Okay, as long as you can see the slide.
But yeah, try putting it in presenter mode, just as if you're presenting, a slideshow live, because I think that'll work.
Yeah, I'm clicking that and it's not moving into slideshow mode. So I'm afraid that this might be the best that I can do right now. So let me just move on. And as I said, I attempt to get through this in about 15 minutes. And there will be 2 ensuing presentations. So unless there are any burning issues or there's something that's dreadfully unclear, we'd like to attempt to reserve the questions for the end. But again, I'll just ask Joel if anything pops up that looks burning, feel free to interrupt me. Okay, so I won't have a chance to dive into all the particulars here, but one of the key points that drives this is the observation that reproducibility in machine learning for health research still has a ways to go. And there was a rather prominent article that was published not long ago in Science Translational Medicine that included a variety of evaluation metrics, including technical reproducibility, statistical reproducibility, and within the machine learning universe, health research machine learning underperformed relative to other domains. This is actually a screenshot from a web page that summarizes part of the work performed by a couple of folks at the Center for Information Technology, the Center for Information Technology Policy at Princeton. And it's just a running list of reproducibility failures. And this is just the first of many pages here. And you can see some of the pitfalls that were encountered. I don't want to lapse into too much by way of machine learning lingo, because I recognize that not everyone has a background in machine learning, but a number of pitfalls were observed, including a poor train test split and biased evaluations and data leakage. There are many issues. These are rife in the literature. And I think part of the reason for this crisis of reproducibility has to do, of course, with the data. Oftentimes, 80% of the times it is the data, the quality, the consistency, the availability. But more than that, oftentimes we'll see a violation of some of the basic principles of machine learning. So for example, failure to use an independent test set to assess generalizability of results. And as a reminder, in machine learning with powerful modern algorithms, such as deep neural nets, we can very accurately classify all the elements in a training set. But the idea is not to memorize these data. The idea is to develop an algorithm that can be generalized. That is the true test of its mettle and worth. So failure to cross-validate and assess for generalizability is a recurring theme. Availability of the data pre-processing details and the code. Sometimes journals will mandate that, in other cases they don't. Inappropriate statistical procedures. There are a variety of hyperparameters that we use in machine learning, and there are different ways to search for them, grid search and so forth. But hyperparameter search and pre-processing methods are sometimes poorly explained, including data imputation, which is critical. And this ties back into this fear of overfitting. And again, overfitting machine learning algorithm results in an algorithm that very accurately classifies samples in a test set, but fails in a rather abject fashion when it's applied to a data set that it has not yet seen. And this is particularly problematic when one uses relatively small, highly dimensional data sets and extremely powerful algorithms. There are a variety of steps that can be taken to reduce that likelihood. We'll discuss a few of them at a very high level in a few minutes. And then another, which I don't want to underestimate, but it's imperative, and I actually, one of the reasons I'm attracted to N3C is because I think there's an appreciation here of the importance of this final bullet. There needs to be adequate crosstalk between domain experts, clinical subject matter experts, and data scientists. And ideally, clinical experts who have some basic understanding of the principles of machine learning. A number of other caveats and challenges that we face on a daily basis. Medicine's highly dynamic. Algorithms can grow stale very quickly. We've all seen that healthcare practices can differ regionally. Data missingness and gaps, we'll hear quite a bit about that from Hytham. Occult confounders, and of course, very high stakes in medicine. Our models have to perform well, so it's incumbent upon us to do the best that we can. In the recent publication that I cited, there was a proposal for improving reproducibility in machine learning for health. This is a cross-disciplinary effort that would require participation from the machine learning community, as well as data providers, subject matter experts, and the journals and conferences as well, establishing reporting requirements and requiring code release. Okay, so where are we and where are we going from here? Just a few more slides. So I'm relatively new. By way of background, I think most of you know me, but I'm a physician scientist with a background in infectious diseases medicine and a very deep and abiding passion at the nexus of machine learning and modeling with medicine and biology. And in the short span of time that I've been here, I think it's become abundantly clear to me that NCATS, the Division of Clinical Innovation, the CTSA, the entire N3C consortium has blazed a trail and set a very good example. So, I think everyone on the phone is aware of this today. Massive collaboration resulting in the Enclave, vibrant community that has recognized that there are holes in the data that need to be filled, and proactive steps have been and are being taken to rectify that. Big focus on data harmonization, development of concept sets, templates, and tools, formation of teams that have made advances in the quality domain. So a lot has been accomplished. And I think when I came on board a few months ago, we cobbled a group together known as the GAP Initiative Core Team. And we identified where we thought we might be able to do more. And I think where we landed was that it was now incumbent upon us to integrate and coordinate the efforts across a variety of teams that were addressing individual aspects of quality. The idea was to foster a soup to nuts, good algorithmic practice initiative that minimized duplicative efforts and mended any residual holes in the fabric of quality. So again, it was about enhanced communication among the leadership of a variety of teams tackling good algorithmic practice issues, and the desire to promote consensus and disseminate some of the principles of GAP. So here you see our mission statement, but in short, and I won't read through this word for word, but we're seeking to identify and refine and disseminate best practices to be considered when leveraging large multi-institutional EHR-based and linked databases with an emphasis on techniques, tactics, tools, and strategies that are tailored to purpose and context, and with an overarching goal of promoting reproducibility and generalizability of high quality unbiased research. So this is an overview of the GAP initiative. I think I only have maybe one or two slides at the most left. But again, the goal: integration, implementation, and dissemination of best practices across the continuum from data management to results. We've leveraged the efforts of a variety of teams, and the GAP core team, which you see at the center here. It's not showing up on my computer screen very well. But the GAP core team is composed of leaders from a variety of GAP initiative supportive teams that are driving various aspects of quality, including the data ingestion and harmonization team, the Logic Liaison Team, ADM&S, the machine learning pipeline team. The natural language processing team and education and training domain teams have also been involved. But we can think of the GAP core team as the glue at the center of a hub, part of the hub of a hub and spoke arrangement here, with a remit of, again, cross-pollination among the team leaders that are driving these efforts. These are the GAP initiative or GAP supportive teams, such as data ingestion and harmonization and ADM&S and so forth. We have leaders from these various teams that sit on the core team, cross-pollinate, coordinate, provide input and guidance to the GAP supportive teams, and we attempt to eliminate bottlenecks and monitor progress. So what you see here is a diagram of the 4 quadrants of good algorithmic practice, to which I have mapped the activities of various N3C teams. So in the upper left, you see data quality and standards. So here we're addressing limited metadata, missing data, aberrant units of measurement, and of course, the data ingestion and harmonization team has made great strides here. On the upper right, data pre-processing, imputation, and feature engineering. Here we have variable creation, production of templates based on authoritative concept sets, imputation of missing values, data normalization, feature selection, and dimensionality reduction with an eye toward potentially reducing the risk of overfitting. And a variety of teams are tackling this now in a coordinated fashion. In the bottom left, algorithmic best practices, tailoring algorithms to data set size to avoid overfitting, and the use of regularization, again, to avoid overfitting, cross-validation and a focus on generalizability, and bias avoidance. And then in the lower right, finally, the machine learning pipeline team, leveraging outputs of the other 3 conceptual quadrants and collaborating with other teams as needed to produce exemplars of machine learning pipelines. So again, we have the 4 quadrants of good algorithmic practice to which individual teams have been mapped, and the leaders from those teams participate in the GAP core team. Underneath all of this is the education and training domain team, which spans a wide spectrum. Some selected GAP-related efforts. The book of N3C, you'll hear more about that today. Planning is underway. This is a compendium of experience and insights that are drawing from community notes. It's also expected to include material on machine learning, and we hope there will be a companion lecture series as well. We're in the midst of a knowledge store enhancement project about which you may hear more in the near future. This is aimed at improving organization and findability of knowledge objects in the knowledge store, more consistent code documentation, and promotion of QC peer review of widely used code. So we're working closely with Palantir and other members of the ADM&S team to move that initiative forward. Machine learning pipeline exemplars, of which you will see several in the near future. And you'll hear shortly after this presentation from Johanna on the new Logic Liaison templates that reflect the authoritative concept sets. And then finally, Emily has recently presented, and but her team is working on a scorecard that reflects expanded quality metrics. This would facilitate ongoing feedback to sites who would be able to discreetly see where they benchmark with respect to other sites when it comes to data quality. And the team is also attempting to implement some means of detecting implausible or outlandish measurements. In the interests of time, I won't go through all of the other potential ideas in detail. Collaboration with FDA, collaboration with the NCATS Division of Preclinical Innovation, the Office of Data Science Strategy. But I think going forward, we'd want to leverage enclaves like N3C as a test bed to evaluate machine learning algorithms of potential value. We've got lots of high quality harmonized data, well-chosen machine learning algorithms. We can test for generalization of predictive algorithms and refine those as needed. Here's the list of the stakeholders. So thanks to the GAP core team, Emily Pfaff, Peter Robinson, Johanna Loomba, Shawn ONeil, Hytham Sidki, Ken Wilkins, Harold Lehman, Hong Fong, Andrew Williams, Palantir, several representatives, and myself. I chair that team. And then the broader stakeholders, which is basically everyone at the bottom. That's it for me.
That's great. No, thank you. And there's a question in the Q&A, and I was wondering something similar. Question is from Layla Ramsey. Curious how this initiative intersects with the FDA GMLP.
Well, that's something that we want to talk to them about. The other, and I've spoken to Joni about this. In addition to that, I think there is an opportunity here to potentially influence their guidance document on software as a medical device, which, as you know, was put forth a few years ago. But I think we can add to that and make it stronger as a team. But absolutely, that's on the radar.
Yeah, and I should say, so we also are actually working with Brandon Gallus from the FDA, and he's probably a little bit more in the imaging space, but the notion of templates, which he calls MDDTs, I'm sure it's not just him, it's the FDA, where we have templates for activities, well, validation templates, which can be used by organizations who are applying for clearance. The notion being that you have a certain sort of well-defined mechanisms where you can prove that what you're doing actually makes sense. And that can include data sets and statistical analysis methods. And what you're talking about here with your FDA interaction seems very, very similar. So it's very, very much along the good algorithmic practice context, although I don't think I'd heard it referred to as that.
Right. Well, I must give credit where credit is due. I believe that Michael Kurilla came up with that catchy acronym. So hats off to Michael, and hopefully this will continue to gain traction. So over to Johanna then. I will pause my share here and stop it, and so that other folks can move along.
Okay, Johanna.
Thank you. All right. And let's see, are you seeing my full screen here?
Yeah, looks good.
Okay. So yeah, hi, I'm Johanna Loomba. I'm from the University of Virginia. I'm the Director of Informatics in our iThrive CTSA here. And I also co-lead the N3C Logic Liaisons with Richard Moffett. He's not presenting with us today. He's an extremely busy individual in N3C, but we're really glad to have Richard co-leading this effort as well. And I'll let Andrea and Evan introduce themselves a little bit later. This is a little graphic I've used a few times that shows some of the support that researchers receive in N3C. There's a really nice mix of things that have emerged over the last couple of years to support researchers. And in order to produce publishable results from our research, our teams have to have somebody who can successfully use Enclave tools to create data frames of these study-specific variables. That definitely means, accessing all the education materials and training that's available, leveraging concept sets that have been brought in by data liaisons, and there's a good set of those just coming in this year that we can use that are produced externally and that we can reuse in the Enclave. We have a lot of great support from the Foundry staff, but we definitely have run into in the past a gap around just the ability to create these variables for study-specific analysis. Even experienced analysts can find it a little bit difficult, and as they encounter that learning curve of coming into the Enclave. And so the Logic Liaisons are coders who share best practices and publish templates to provide kind of a solid foundation that will facilitate that kind of work across our community. In 2021, when our domain teams were hard at work working, to move from the design phase through to publication, we assembled this group of Logic Liaisons for the first time. It was kind of in the spring of last year. And at first it was really like a discussion group with 1 to 2 analysts from each domain team, and also some important members from other groups like Palantir staff, the education team, data ingestion harmonization, methods and standards. And our meetings were used to share some best practices, really specifically as it relates to, again, creating variables, using our code workbooks in the Enclave to create variables for analysis. So kind of just one sliver of what the GAP initiative does. And we also were encouraging one another to templatize useful code. These meetings were valuable and we definitely got some good products out of it, but the resources are still a bit scattered and it was difficult for users to kind of find and piece together the most salient things that had gone into the knowledge store. And then also once things were shared in the knowledge store, it was difficult for that code to be maintained. People are just voluntarily putting little bits and pieces of stuff they've worked on out there. And so as the underlying data evolved, those things could become outdated. So now in 2022, our focus has shifted. We are now, thanks to NCATS and CD2H supporting us, there's a small working group of Logic Liaisons, which is really focused on creating some broad use, well-documented, well-maintained templates that really embody many of those best practices that the Logic Liaisons had identified in 2021. So the main products that we're producing this year, this quarter and this year, are these fact templates. And these are very large templates. So this is not just to help you find those COVID positive, but really to give you a lot of facts around patients in these N3C subgroups. This one is published and we're going to show you that today, the one for COVID positive, and we're working on the COVID possible and control patient templates, and those will be available soon. And as you'll see from Andrea and Evan's presentations, our READMEs include a lot of detailed documentation, and the fact table READMEs have data dictionaries, as do the data sets that they produce. So again, the kind of high-level introduction to what our fact tables contain. We have over 100 variables that are generated by these templates, and again, you can use a template or just the table that results from that template. We have demographics about the patients pulled in. We have data partner characteristics. So this is important when you're looking at data around a single patient to be pulling in information about their site, so you know if that data was shifted. Even in level 3, we have a few sites shifting dates. When was the most recent extract of the data? What data model are they using, etc. This is really important for stratifying or filtering the data that you might be using for your analysis. We also have a nice group of social determinants of health variables. They're at the county level, linked by patient zip. Those were curated by the SDOH, the social determinants of health domain team, who's worked with us on it. We have a nice big group of pre and post COVID comorbidities, and right now our SNOMED CT created concept sets are still there, but this week I expect we will have the complete set of externally validated concept sets available to us from the data liaisons, and then their work is going to converge with our work, and all the variables used will use these externally validated concept sets. Again, the GAP initiative is a place where our efforts from these different teams are kind of pulled together. We have key events that happen like during the COVID hospitalization and flags that are created for those and summary statistics about our patients. All of these are available again, just kind of at the patient level level of detail, 1 row per patient. But then we also have a visit day summary. It's our all facts table, and you can get all of the above visit by visit for each patient that's been seen, along with important flags, and Andrea will show you that. We also have, in addition to our main fact tables, which are ever growing, we also have these data evaluation templates that you'll see today, and we'll be adding to those over time. These help teams really make good use of the data once they wrangle it into, something that they want to use. So the first template that actually it'll be the second one presented today, but is a data density by site and domain. And this one is really looking at data across all the OMOP tables. I took a picture where I cut off the axes because we can't share real data with you. You can see like the level of detail in these visualizations, and you can drill down into it when you're using it. But the ones that they're going to demo for you today are using synthetic data. So there's only like 5 fake sites in the synthetic data compared to over 70 that are in the real data. So this is just to give you a sense of the real ones that are in the Enclave if you log in and import them into your project. The second template here produces really more of an analysis of which variables are being sent in by which sites. So when you have a final, synthesis of data, you've created your study-specific variables, you can look across sites and see, are there any variables that are not showing up for particular sites? And if so, maybe you need to drop those sites from your analysis if it's a primary outcome. So these kind of serve complementary purposes as people begin to look at the quality of the data as it pertains to a specific research question. So lastly, I just want to say that we're available at the N3C office hours. So feel free to come and visit us there. Those are on Tuesdays and Thursdays, and you can find them on the main CD2H website for N3C. We'd be happy to show you how to use these templates and apply them to your own research question. And I think I'll pass it on to Andrea.
Thank you, Johanna. I am Andrea Joe. I am a data scientist at the University of Virginia in the same CTSA as Johanna. And I am one of those friendly neighborhood logic liaisons that Johanna just talked about. And today, just like to take a few moments to share with you the updates about our templates. So they can be found in the Knowledge Store located here just by searching Logic Liaison. So the first one is our COVID diagnosed or lab confirmed patients template. In this knowledge object, we provide sample code that can be viewed in these example workbooks or imported into your existing workbook and modified using the instructions in the README. There are also summary data sets, including a visit level table and a person level table for each level of data access. So your level 3 for LDS or your de-identified for level 2. And so in these folders, we can see this all facts table that Johanna mentioned is your visit level table. And so there's a single row for every patient on each visit day, including any date where a fact was recorded in any of the OMOP tables, along with flags for visit day relationship to key events such as their COVID index event, which would be their diagnosis or their lab test, or COVID-related ED and hospitalization visits. And then the patient level table, our summary facts table, it contains 1 row per COVID positive patient and a number of commonly referenced facts and indicators derived from the N3C data sets. So just to give you a small taste of that, since we can't show our data, I've cut off the side of the screen, but we can see here some of the columns that are provided. So first we've got their indexed event dates, and then a lot of their demographics, followed by those the data model information, and then those SEOH variables if you're in level 3, some of the many comorbidities that we've flagged here, and then finally the flags related to their hospitalization or ED events, or even other events such as death during or death for these COVID positive patients. And so these variable descriptions are embedded in this data set. So as you click on them, just to learn what they are, you can read what they are, but it is also found in our README located in this knowledge object under the data dictionary section. So you can see all of them here. Other useful information in this README includes some introductory logic liaison tips about N3C data, as well as guidance on how to modify this particular template for your project needs. So there are also descriptions of each node, what they accomplish, that serve as a good starting point for understanding how we find these facts and where to implement any changes you may need for your code. And then finally, there is a section for release notes, which is where we'll put any updates or modifications we've made since the initial publication of this template. And so the second template that I'll show you guys today is our systematic missingness by site and study variable. So this knowledge object also provides the sample code, and this code will generate a visualization that identifies the sites that are systematically missing meaningful data for the study variables of the input fact table, which is currently defaulted to the patient level fact table that I just showed you. But here I have a version of this using synthetic data, where we've made that table using the synthetic data in the Enclave, just to give you guys an idea of what to expect. And so this input can be replaced with your study team's desired data set to assess for missingness prior to analysis, in case you want to exclude any sites that don't send data related to your key variables of interest, or maybe even apply some of the strategies that'll be discussed at next week's community forum by Hytham. And then once run, this final node will produce a visualization where the darker blue dots indicate missingness. And so for this template, there is also a README that provides similarly structured information as seen in the COVID positive template README that I mentioned just a few moments ago, including node descriptions. And that is it. So now I'll turn it over to Evan to talk about our final template.
Hey, so I'm not sure that I have screen share ability. Is it possible that I could be promoted to have that?
Maybe Andrew, do you want to share your screen and he can talk through it? Are you able to go to his template?
Usman, are you able to promote people?
I can.
Hey, Joel, no, I think An should be able to do it.
I think Andrew sharing your screen will work fine. We can
Okay.
just do that and it'll work for sure.
Okay.
So
Yeah. So, sorry to put you on the spot, Andrea.
oh, joins me. I actually just got promoted.
Okay.
So I can take over the screen share. Thank you, though.
Thank you.
Okay. Okay, so can you see my enclave here? All right, so I'm Evan French. I'm a data scientist at BCU, working with the Logic Liaison Team. And I've worked on this template for data density by site and domain. And what that means is we look at all of the sites that are contributing data to the N3C enclave, and then we look at the density per person for each of those sites for all of the major OBOP tables. So, you know, like drug ERA, condition occurrence, drug exposure, et cetera. And we go through each of these and we calculate what the median density is per patient, per site. And then we find the median of medians to be as like, this is our expected value. And then we calculate a statistical measure called the median absolute deviation. And this is going to tell us for a given site, for a given OMOP table, how far off are they from what we expect. And then using that, we generate this little visualization, which just gives us a nice visual cue, with dark red being things that are far from what we're expecting in terms of density per person, and the lighter colored ones being closer to that median. So this is important when you're doing your study. So for example, if you're using death as an outcome, then you'd want to know if one of the sites is way off from what you're expecting in terms of number of deaths. So some of these sites might be contributing near 0 deaths, and that's not right. And you probably don't want to be including them if you're trying to measure a death as an outcome. Ditto for things like drug exposure. If you're doing flags for was this person exposed to a certain drug, you're not going to get a good coverage there if a lot of your patients don't have any medication information. So similar to Andrea's, this is published in the knowledge store. You can search using Logic Liaison template and find all of our stuff. We have documentation following a similar format, listing what the purpose and use are, how it's working technically, data dictionary, and then release notes. This was just released in its first edition, so we don't really have much in the way of changes documented yet, but if we update it down the road, all those changes will get recorded here. So I think that's about it for me.
Great. Question in the Q&A, really good question. Halia Amarian, is there a data table with the same detailed information for COVID negative patients?
So yeah, I'll answer that. So that is on our roadmap. This coming month, we'll be releasing another template for the controls. Of course, the controls that are pulled into N3C, that's just based on the phenotype for N3C, which means the patient had at least one negative test. That does not mean we can really be omniscient and know if they've ever had COVID.
Right.
That's coming.
And no, thank you. No, that's great. And another question, how does this play out for PPRL linked data? So say you've got death registry or
Yeah, so we use right now the main death tables that are available to everyone, since the DURs require special permission to use the linked data, but we could absolutely create a template for enhancing death data using PPRL for an example.
Great. Well, this is really excellent. It's very great to see these concrete examples. It's extremely enlightening. So Shawn ONeil is going to talk about update from education and training domain team.
Absolutely. Thanks, Joel. Can everyone see my presentation appropriately?
Yeah.
Thanks. All right, so a little bit about the education and training domain team. We're a brand new domain team, co-led by myself and Karen Crowley at Brown. And this is essentially a forum, an umbrella forum for the development management of anything N3C related in the space of education and training, whether it be sort of training modules or, your particular local institution wants to run a internship program and you'd like some support and ideas on how to do that. You can stop by the education and training domain team. We meet every other Thursday, including this Thursday, and you can find the time and info and location and all kinds of details about it at the shown URL here, tinyurl.com/etdt readme. I think it's worth reviewing a little bit the training and educational resources that we have together so far, most of which are available inside of the Enclave, a few of which are available outside of the Enclave. But if you are outside of the Enclave and there's one URL, you should remember about this. It's our main CD2H training URL, which sort of overviews most of what I'm going to talk about here today. The first thing that's mentioned there is our orientation sessions. We still run 2 orientation sessions. They each run once per month. So every 2 weeks, we're running either session A or session B. And the session A orientation really goes into some depth about what the data is, where it comes from, caveats for using it, a little bit about the OMOP schema, as well as the sort of community and policies and processes that are involved with N3C. Orientation session B is a really sort of a fire hose quick review of all kinds of things Enclave technology, whether it be the concept set browser or code workbooks or Contour and so on. You can find where those are at on the main N3C calendar, which is the link I'm showing here. Something else that we have available is our training portal. This exists inside of the Enclave. So from the Enclave homepage, if you click on the big training material button, you'll find inside of there the training portal button. And these are broken into what we call modules, which are really some mix of video, text, and potentially example code and resources. And some of the topics covered, everything from navigating the Enclave, understanding OMOP, using the tools that are available, as well as some of the processes, how to submit a download request when you're getting time to publish your results and things like that. Newly available in the training portal are some PPRL intro and guides, which we talked about as well previously on a couple of community forum meetings. One thing that's worth noting here is the suggested modules button, which is in orange in the upper right. That'll give you a quick introduction and brief orientation of what these different modules are, and as well as which ones you might want to check out depending on where you're at. So if you're brand new, there'll be a section of that button that tells you which modules you should check out first, or once you've been rolling and you've been doing research for a little while, it'll tell you other kinds of modules you might be interested in, and so on. Another resource that's available in terms of training and education is the community notes application. And this is sort of like a community developed wiki, which lives inside of the Enclave. You can access it again from the homepage under the training material link in the community notes button. These are community authored and they come in several flavors. There are articles, FAQ items, as well as code snippets. And there's a really rich tagging infrastructure that's available for these to help sort of organize and find information. And these things can also be linked to particular knowledge objects in the knowledge store, or particular concept sets, or particular training modules, and so on and so forth. And before I lose track of it, it's also worth mentioning that the official documentation for the tools available in the Enclave is pretty good. If you go to the Enclave homepage, and again, your training material, there's a button there for documentation, which will take you to the official documentation for the platform. And it's really very searchable. That's what I really appreciate about it. If I want to know how to do something in Code Workbook, I can just search Code Workbook and the thing I want to do and get some information about it. A couple of other neat things we have available that you may not be aware of. We do have a training workspace and some training data, by which I mean data that you can use to learn. So you can learn and use tools in the Enclave on example data before your DOR is complete. If you want to find a space to play around, if you go to the projects and files on the Enclave homepage, under projects, if you search for training area, the one that will show up is N3C training area. And inside of there, there's even a practice area folder. And inside of that practice area folder, you can create a subfolder for yourself where you can create your own, contour analyses or code workbooks or whatever it may be. The other interesting thing that we have available is if you were to click on projects and files and look under the data catalog, we have two notional data sets, also called fake data sets. The first one is SynPuff, synthetic data. This is a data set which is generated based on some Medicare claims data. So it's a little bit older and the data is interesting, but it's not really quite to the richness of N3C data. And in particular, the SynPuff synthetic data doesn't contain any COVID-related data. We also have available a Cynthia notional data set. So this is a data set that's based on a probabilistic patient model that was published in the early days of the pandemic. And so this is actually really interesting because it has COVID tests and things inside of it, and it just looks a little bit more recent. The downside of the Cynthia notional data is that it's a little bit more synthetic. So it doesn't have the diversity and richness of the code sets used. There's less data missingness and so on and so forth in the Cynthia notional data, but the synthetic data does have a little bit richer data in terms of diversity. The other nice thing about the Cynthia notional data is that we've mapped it a little bit more carefully to the N3C OMOP features. So there are notional data partners in the Cynthia notional data. There are notional macro visit tables in the Cynthia notional data, and so on and so forth. And these two things are what was shown by Andrea and Evan and Johanna when they were displaying those results because they are notional and are not protected information. Another nice feature of having notional data that we can use to develop training and educational materials with is that we can use them in our Enclave users group. This is a group that meets every Friday at 10 a.m. Pacific time or 1 p.m. Eastern. We alternate every week between sort of a topic presentation and an open discussion, just sort of water cooler chat. And some of the past topics that we've had include, branching and managing data branches in the Enclave, cohort matching, authoring templates, understanding mortality data, and so on and so forth. And because this is a public forum, all of our examples and meetings are recorded, and you can actually find them indexed in the training portal. So in the training portal that I showed, there's an entry for the Enclave users group, and you can see all of our past meetings, the topics, the videos, and the demos that were developed for those. This coming Friday, we have using social determinants of health data. So that should be a fun, interesting topic to learn about. And to find announcements about Enclave users group or other new Enclave training related things, you can check out the N3C training Slack channel. We have office hours, which we run actually twice a week. These are Tuesdays and Thursdays, again at 10 a.m. Pacific, 1 p.m. Eastern. And questions for office hours can really be pretty much anything. If you're not sure how to use an Enclave tool effectively, or you're running into some bugs and you can't figure out how to fix it, your code isn't running very efficiently, you're not entirely sure about some properties of the data, you want to help figuring out the data use request process or other processes and procedures, you can feel free to stop by our office hours. And if we don't know the answer, we'll try and help you figure out who does know the answer. Newly, we've got, as Johanna mentioned, Logic Liaison members showing up, so we can handle a bit more people simultaneously during office hours. And it's actually been really great to have some of the Logic Liaison members there because many of them are engaged in really active research communities as well, and they can actually provide a little bit of support for research design and sort of questions of that nature. One thing that is just getting started that David mentioned, which is a book of N3C. This is very heavily inspired by the Book of Odyssey project, which documents all things Odyssey and OMOP. And this is just getting off the ground. There's a lot of interest in it. And so what we've done is we've put together an editorial committee so that they can sort of decide on overall structure and flow to make sure everything goes together well and there's no missing holes or back references that are missing and so on and so forth. And the representatives on the editorial committee come from a variety of N3C groups, including data ingestion harmonization, governance and admin, ADM&S, logic liaisons, machine learning, and of course, educational training. And before I wrap it up for today, I just wanted to reiterate again that survey that was posted at the very beginning of our chat today, which is this Enclave Tools user survey. This is put together by Saad at Palantir. And really just to give you a flavor of the kind of questions that are being asked, they're looking for feedback on some of the Enclave tools like contour and code workbooks and repos, as well as some of the N3C specific tooling like Knowledge Store and the training portal, and things like support channels, whether it be tickets or office hours or what have you. And that is the end of my presentation.
Thanks. That was great. Any questions? So Shawn, so I have a question in terms of this. A lot of this, a lot of the work that you're doing, I think would be really very interesting to offer students in an intro biomedical informatics course or an intro health informatics course, independent of COVID. And obviously with the synthetic data sets, it would be possible to do that. Have you thought about that or gotten any interest from folks doing that, or do you think that's just too much of a challenge on your bandwidth?
We have thought of doing that, and in fact, one of the projects that I didn't mention in my little rundown there is a project which currently is sort of like has its encompassed scope, but there's a small subset of institutions who are working on a pilot short course which does utilize N3C data for training biomedical research students. I believe, and I've gotten some confirmation that this can be done if so long as you are having your students do actual research-like projects and it is COVID related, then it's okay for student projects and classes to do that. That said, that project is kind of thinking about, how do you navigate the DURs and students and all that kind of thing. So they'll definitely be leveraging those notional data sets that I mentioned as well. And the fact that we have our education and training domain team, if you do have a course that you want to run and you want to sort of give students experiential learning experiences with N3C, you can go ahead and check out our domain team, and your DUR could be affiliated with our domain team. And of course, we'd recommend that you also affiliate with whatever relevant clinical domain team pertains to the class.
I see. Okay, so then the idea would be the class, if one was going to use as a model problem XYZ and COVID, then they'd affiliate both with your domain team and whatever DUR seems closest to what they'd be doing projects on. Great. And Richard says N3C also hosted Pediatric Prediction Challenge with BARDA, and this is also something where there's been some discussion about using the environment to run tenant environment to run machine learning codes linked to N3C. Discussions with Sam and Ken. Johanna, do you want to talk? You have a comment?
No, just like no, I just responded to Layla there
Okay.
about her running. I think that's adequate. Yeah.
Okay, great. Other thoughts, comments? I guess we're at time. So this is really extremely informative, and I'm glad it was recorded because I think people want to reference this. So thanks and have a great week.